Bismillahirrahmanirrahim. So students, now we are going to use the software named as WinProLadder used for the Fatek PLC. Now in which we have different options like file, edit, view, project, ladder, PLC, tools, window and help. So first of all we will select the file option, in which we have new project and open. Because we are using this for the first time, so we will select the new project. Open is for if we already work on this simulation and we already have some simulation files, so if we have to open this file, then we select the open. Now I am selecting the new project, in which project name, let's say Fatek PLC task 1. Okay, now the PLC that we discussed earlier, named as Fatek PLC FBS 20MA. The model of the Fatek PLC that we discussed earlier in detail was the Fatek PLC FBS 20MA. So here we have to select that model, FPS 20MA. Press OK. Now students, here we have also a description option and we have also a calendar option. Here we have some specifications of this Fatek PLC, of this specific model. A description in which you can describe the project. In description, it is optional. Let's say we are going to discuss logic gates, so logic gates, just description I described. Now calendar, it is optional. If you check this option, then the software will automatically note the time and the date in which you are going to run your project. Press OK. Now here is our main window of our WinProLadder software, in which you can see different kinds of things here. These are inputs, outputs and different reset, horizontal, vertical options, settings, reset, timers. We also have a timers here, counters, functions, delete options, delete vertical, delete horizontal. All these stuff we will discuss. So first of all, we are going to discuss the very basic gate, which is nothing but simple AND gate. In simple AND gate, we know if both our inputs goes high, then our output goes high, because it is like multiplication. 1 into 1 equals to 1, 1 into 0 equals to 0, 0 into 1 equals to 0, 0 into 0 equals to 0. So for this we need this, and let's denote our input x0. Why x0? देखें students, as I told you earlier that our input should be denoted by x symbol, and our output should be denoted like y, y0 to y8, and inputs x0 to x13. This specific Fatek PLC FBS 20MA has 14 inputs and 9 outputs. So first input, and we also need second input x1, and output y0. Okay students, now now we have to simulate this task. How? Let me tell you how. Select this PLC option, select this simulation option and run PLC. Now our PLC is running. As you can see, this first of all off. Look, 0, this switch is also off and this switch is also off, so output also goes low, means 0 into 0 equals to 0. Now if I on this switch, 0 into 1 equals to 0. Now what if I own both switches? Now you can see our output will also glow high. You can see 1 into 1 equals to 1. So this is a simple AND gate logic. Now we are going to discuss a very simple another gate logic, which is OR gate, in which any of the input is high, then our output will also high. Means it is like adding 1 plus 0 equals to 1, 0 plus 1 equals to 0, 0 plus 0 equals to 0, 1 plus 1 equals to 1 in simple Boolean algebra. Okay, so now first of all stop the PLC. Now select the input named as x2 and output named as y1. Select the vertical option here and horizontal option here. My mistake, sorry. Undo here. Now press another, select another input here named as x3. Okay students, so now press the cursor, run PLC. Look, both the switches low, means 0 and 0, so our output will also be 0. Now what if any of the input goes high, then our output will also goes high. You can see like this here, any of the input goes high, our output will also goes high, because 0 plus 1 is equals to 1, 1 plus 0 is equals to 1. And when also on this switch, you can see our output will also high, 1 plus 1 is equals to 1. So this is a very simple OR gate. Now we are going to discuss another very simple NOT gate. How to implement it? First of all, stop the PLC, select this option here named as x4. So this is our input, and the output here named as y2. So here's our NOT gate. Select this option and PLC, run PLC. Off. Look, it is normally closed switch. Normally closed means look, abhi this switch is off. When we turn on the switch, when we give the power of this switch, the normally closed switch, it suddenly becomes open their contacts and become open switch. And when if we turn off the switch, like wait, now when off the switch, so it becomes in its original position, means normally closed, so the power goes to the output. So this is a very simple NOT gate. Now we are going to implement the NAND gate. What is NAND gate? Let's discuss that gate. NAND gate, the truth table. Here we have the truth table of the NAND gate, in which when both of our inputs becomes low, then our output will high, and when any of our input becomes high, our output will also high. Our output will only be 0 if both of our inputs high, else our output will always high. So now we are going to implement this gate in our WinProLadder, Fatek PLC ladder logic programming. First of all, I'm going to select this input, stop the PLC, yes. Now select this here named as x5. Now select the output named as y3, the vertical line and the horizontal line, again a blender by me. Select the horizontal line, yes. Now select another input here named as x6. So now students, this is a very simple, nothing but NAND gate. Select the cursor and PLC1 PLC. Our output will only goes low when our both inputs become high. So let's discuss first this last case. Okay students, so on and on. Both switches are on at this state, and you can see our output is 0, as you can see. Now what if I off one switch? Then you can see, now you can see, if any of the switch goes low, our output will become suddenly high. If any of our input becomes low, the output of our switch will high. And in 0 case, in both, when our both switches will be 0, then our output will also glow high. As you can see, our output light glows, is glowing, means this ladder logic is basically fulfilling our requirements of NAND gate. Now we are going to implement NOR gate. In NOR gate, the output will only glow high when both the inputs will be 0, else our output will also be 0. Okay, so now let's implementing this ladder logic in our software. First of all, stop the PLC and then yes, NOR gate, and then select first input named as x7 and the another input named as x8, yes, and our output named as y4. Now just simple run the PLC and select this option here. Students, when both of our inputs will be 0, then our output will be high, else our output on every condition will be 0. So first of all, let's close both the switches off and off. As you can see, 0 0, but our input will be high, 0 0, and our output will be high. What if any of the switch will become high like this? Our output will be 0, as you can see. Now I'm on this switch and turn off the switch. As you can see, same condition. Now both switch will be on. You can see when both switch will be on, our output will also 0. Our output will be high in only one case, when both of our switch will be off, like this, off and off, because these are normally closed switch. So this is our simple nothing but NOR gate. Now we are going to implement our XOR gate. XOR gate, here is a truth table for the XOR gate, in which our output will be high when our inputs differ. Means to say that when one of our input will be high and the other of our input will be low, then our output high. Else if both of our inputs are in same state, then our output will be 0. So let's implement this logic. First of all, PLC and stop PLC, and select this option here named as x9 and x10. Okay, vertical, before vertical, this option, output named as y5, and now vertical, and then horizontal, and then horizontal. X9 and X10. Okay, so now select this and run our PLC. So students, if both of our inputs have same state, means both will be low or both will be high, in both conditions our output will be 0. Else, if any of the input state differ from the another, then our output will be high. So now first of all, off. Now all our inputs are 0, 0, 0. So our output will also be 0. And now what if I turn on both the inputs, means high and high. When I turn high this switch, then this switch will automatically becomes high because both are X9, and similar case for that switch. Okay, now each of the switch have same state, means both switches are on high state, so our output will also 0, as you can see. Now what if any of the switch becomes low, let's say 0. Now you can see that our output will be high, like this. So this basically logic fulfills our requirement of the simple XOR gate. Now we are going to implement XOR gate. XOR gate in which our output will be high when our both inputs have same state, means it is totally opposite to the XOR gate. So it is similarly this, but the difference is at the output. Students, let's see. X11 X12 output difference at only the output, so why 5? As you can see, both the outputs normally closed and normally open. Now vertical, horizontal and horizontal. X11 and X12 PLC WinPLC. Error count 0, warning count 1. Okay, let's watch. I think the logic is right. Let's, yes, our program is running. Oh, same output, that is why. Stop PLC, named as Y6. Now simply run PLC. Now our output will only be high when both of our inputs are in the same state, means when both will be high or when both will be 0, then our output will only be high. Otherwise our output will always be 0, like this. Off and off. Both of our outputs on the same state, means this is also off, this is also off, 0 and 0. Okay, so in 0, 0 situation we have our output high, means the LED will be glow. When if any of the input goes high, then our output LED will glow off, like this. on, like this. Okay, X11 is on and X12 is off, so that is why 1 0 is equals to 0, as you can see that. So this is a very simple XOR gate. So students, this is how we can implement our simple logic gates in WinProLadder. Students, we can also use timers here. How we implement a timer, let's discuss. Here we have a timer option. You can select this option like this. Oh, again mistake. First of all, stop the PLC. Yes. Now select the timer option. So basically in this pop-up box you have to write basically two values in your timer. In the first option you have to write the timer number. This timer number then you will use in your further options in the program. Timer number depends on which type of timer you are using here. For example, let's say we need to switch on our output for 5 seconds. So before discussing this, let's discuss. Here you have a system configuration option. Open this and we have a memory allocation option, in which we have different types of timers: retentive, 0.01 second timer, 0.1 second timer, 1 second timer, retentive 16-bit counters. We have different counters and registers here. So if we want 5-second delay, so means 1 2 3 4 5, so we use 1 second timer totals. ठीक है, 1 second timer totals, and T200 to T255. okay, so I will use this timer if we, let's say, need to switch on our output after every 5 seconds, after 5 seconds, simple. So I will select this 1 second timer here, which is ranged from T200 to 255 according to memory allocation. Because this is my first time in this PLC program, I write first value, which is T200, in the first option of this pop-up timer box. Okay, so let's watch, students. T200, okay, means 1 second timer. It is automatically written here. And now the second value is PV, which means preset value of the timer. This PV means after this value your timer will start from 0 again. For example, I write 5 in PV value, then after 5 seconds timer will start again from 0 to 5. Got the point? After writing the value in the timer pop-up box, click, let's say 5 here. Okay, yes, okay. So here is our timer. So let's implement the logic. So now I am writing a code in which I basically set our output on for 5 seconds. Okay, so click this, let's delete this and delete this too. Now let's make a code. For example, input named as X13, yes, and yes, X13, and output named as Y7, yes, Y7. Now this stop button, we also need to the stop button, which will reset the timer. So basically select this and named as, let's say, X14, I think, yes, X14, and same output reset coil because this is our stop button, reset switch button. So Y7. Now take this, press select this Y7, and now I'm going to select a timer here, T200 1 second timer, and preset value 5. Now so now basically what happened in this what is going on this logic. Wait, there is something missing here, and that will be, yes, our main output here, named as Y8. Now I think it's all right. So what happened here, when I pushes the button, when I push this button, that output will become activate, and then timer start its counting, and after 5 seconds output will be high. And when we press this button, this basically reset the output of this, and our timer will also reset. Okay, so now PLC, run PLC, wrong, what's, yes, duplicate, it's okay, it's all right, not to worry. So now look carefully, when I switch on this button, then our timer will also start its time. Look, when I activate this switch, the output becomes activated, and this output also goes here, and the timer starts counting. Now what if I close this switch? The timer still counting because the output is set. Now we have to use the stop button on this switch. Our time will become reset 0 0. Okay, now close this switch, again open, on the switch, our timer starts counting. After 5 seconds our output goes high, and when we use this on, our timer will become reset, and when I off this switch, again timer starts counting because this switch already high. So this is the basic intro of the timer, how you use the timer in Fatek PLC. I think it's sufficient for today. Inshallah we will discuss more about this Fatek PLC, and I think today it will be sufficient for today. Take care. Allah Hafiz.